Hi, this is Nimla Rednam. In this video, we are going to discuss exercise 3.4, which is the last exercise in chapter 3, Understanding Quadrilaterals from NCERT textbook class 8. Before going into the exercise, I would like to do a quick revision of this entire chapter. So let us start. So if you remember, we started off the chapter with simple closed curves, polygons, and then we came to quadrilaterals, and then we looked at few cases of quadrilaterals, right? So let me put the heading quadrilateral. Okay, quadrilateral. Now here, what is a quadrilateral? It is a polygon. I'm going to write only the keywords consisting of 4 sides, right? Now what is a polygon? It is a simple closed curve made up of line segments. Now, what is a simple closed curve? Curve is the path traced by a point. Closed is when you have the starting point of the curve as same as the end point. And simple is when it does not cross over itself, right? So that is about quadrilateral. Now we looked at few quadrilaterals. Okay, the first one that we looked at was trapezium, right? That was the first one. The second one that we looked at was kite. The third one that we looked at was a parallelogram. And then we looked at special cases of parallelogram, that is a rhombus, a rectangle, and a square, right? Now, like I mentioned in the earlier video, when we talk about these different kinds of quadrilaterals, we need to have clarity about the definition of that particular quadrilateral. That is, what is the necessary and sufficient condition or the criteria that makes the given quadrilateral a trapezium or a kite or a parallelogram, so on. So this definition you need to have a very good clarity, right? For a quadrilateral to be a trapezium, what do we need? We need one pair of opposite sides have to be parallel to each other. Okay, that is the criteria, right? Now for kite, the definition they have given was you have two distinct pairs of consecutive sides of equal length, right? You remember? But then I try to explain and try to give a different, more clear definition, that is one diagonal. Do you remember? One diagonal is the line of symmetry, okay, for the quadrilateral. If one diagonal is a line of symmetry, then we say that it is the given quadrilateral is a kite, okay. Now coming to parallelogram, it is a quadrilateral that has two pairs of opposite sides as parallel, right? In trapezium, you have one pair of opposite sides parallel. In a parallelogram, you have two pairs of opposite sides parallel. Now, rhombus, rectangle, square are special cases of parallelogram, but I want the definition from the quadrilateral, okay? Instead of from parallelogram, I want to have the definition starting from quadrilateral, right? So, I'm going to say that a rhombus is a quadrilateral which has all sides as equal. So, can I say equilateral? Correct? And then coming to rectangle, if you remember, it is equiangular. All angles are 90 degrees, that is to say that all angles are equal. Okay, and then coming to square, it is both equilateral as well as equiangular. That is a square. So this is about the basic definition, that this definition has to be, you need to be thorough with this, okay. And then looking at this definition, it's clear that a regular quadrilateral is nothing but a square. If you remember, the definition of a regular polygon is that the polygon is both equilateral and equiangular, right? So a regular quadrilateral is nothing but a square. Okay. Now we will come to the properties in a while. Before going to the properties, I want to depict these types of quadrilaterals in form of a Venn diagram, because most often you must have noticed that the questions that are framed are in the fashion, state whether true or false, all rhombus are parallelograms, or all kites are parallelograms, or all rectangles are trapeziums, so on, right? So these are the kind of questions that you tend to see very often. So if you remember this Venn diagram and try to understand this Venn diagram, these questions are going to become much less confusing and very easy. So first I'm going to draw the set of quadrilaterals. Let us say capital Q, right? Now here all trapeziums are quadrilaterals, right? So it has to be a subset. Let me draw this as set of trapeziums, correct? Now kite is a quadrilateral, so it has to be a subset of quadrilateral. One diagonal is a line of symmetry. Now this is not a condition for trapezium, so all kites are not trapeziums. There might be an overlap, so I'm going to just draw an overlap. We'll see what that overlap could be, okay? But this is going to represent our set of kites. Okay. Now coming to parallelograms. Now you know that all parallelograms are trapeziums, because if you have two pairs of opposite sides as parallel, naturally one pair is parallel, right? So it has to be a subset of this T, set of trapeziums, right? However, okay, has to be a subset. Now you also know that there are few like for example, we have studied rhombus. It is both kite and parallelogram, right? So what I'm going to do is I'm going to draw the parallelogram as this. This is my set of parallelograms. Okay, I'm going to represent it by capital P. Right? Now here the intersection of P and K, that is this particular part, I'm going to write this one as set of rhombus, because I know that a rhombus is both a kite and a parallelogram. Okay, so this is the set of rhombus. Now what about rectangle? All rectangles are parallelograms, so it is a subset of parallelograms, right? It is a subset of parallelograms, and some rectangles can be rhombus as well. So there has to be an intersection for that. So I'm going to draw it like this. This is my set of rectangles, RE. Okay. Now here the intersection between this rhombus and this rectangles is nothing but our squares, S. Right. Finally, we have the set of squares, which is S. Right? So this way, if you can understand this Venn diagram, the questions that most of them even in our exercise 3.3, 3.4 are going to be very simple. Okay. Now coming to the properties of these 6 quadrilaterals, what are the properties that we looked at? For a kite, if you remember, we have seen, for a kite we have seen 4 properties. One is that the diagonals are perpendicular to each other. Okay, diagonals are perpendicular to each other. That is the first property that we have seen. And one diagonal is bisected. One diagonal is bisected. And next we have also seen that one pair of opposite angles are equal in measure because of the line of symmetry. That is a consequence of that. One pair of opposite angles are equal in measure. Okay. And then one more property that we noticed was that the other diagonal, which is not the line of symmetry, okay, the diagonal which is the line of symmetry is the angular bisector for the other two angles. the unequal angles. Now see, one pair of opposite angles are equal and the other pair is bisected by the line of symmetry. Okay, so the line of symmetry is nothing but the angular bisector. So these are the four properties that we have seen for a kite. Similarly, for a parallelogram also we have seen four properties, if you remember. The first one was opposite sides are equal. Next one was opposite angles are equal. Angles are equal, right? And then we have the adjacent angles are supplementary. Adjacent angles are supplementary. And then we have seen that the fourth property was that the diagonals bisect each other. They need not be equal, but they bisect each other. Okay, so I'm going to write it here. Diagonals bisect each other. These are the four properties, right? And then coming to rhombus, we have seen that all the properties of parallelogram hold true for a rhombus. Additionally, the diagonals are perpendicular to each other, correct? And do they bisect each other? They in fact bisect each other because the rhombus is a kite with two lines of symmetry. So they do bisect. So the diagonals are perpendicular bisectors of each other, right? So that is about rhombus. So rhombus, all the properties of the parallelogram hold true, okay, and all the properties of a kite also hold true. And then we have seen that the diagonals are perpendicular bisectors of each other. Coming to rectangle, all the properties of parallelogram hold true, right? And the diagonals are equal in length, okay? The diagonals are equal in length. So this is about rectangle. Coming to square, all the properties of rectangle and rhombus will hold true, correct? And then that's it. All the properties of rectangle and rhombus will hold true because that will take care of diagonals being perpendicular bisectors of each other. So this is about the properties of all the 6 quadrilaterals that we have looked at. So now that we have revised all the properties and all the basic definitions, let us go to our exercise. So here, state whether, the first question, state whether true or false, all rectangles are squares. Now clearly this is false because we have seen just now that all squares are rectangles, but all rectangles need not be squares, right? Second one, all rhombus are parallelogram. This is true, right? Because you've seen that if you look at this, they're saying that all rhombus are parallelograms. If you look at this is the set of rhombus, right? This here is a set of rhombus, correct? And these are a subset of the set of parallelograms. Therefore, I can say that all rhombus are parallelograms. So, this statement is true. Okay, so the second one is true. Next, all squares are rhombus as well as rectangles. Okay, now this is also true. All squares are rhombus as well as rectangles. If you look at this is your squares, right? Now all these are rhombus, okay, that is their equilateral, as well as their rectangles. So this is the overlap of rectangles and rhombus here, right? So therefore this statement is true, that all squares are rhombus as well as rectangles. Okay, next, all squares are not parallelograms. Now this is false because clearly squares is a subset of the set of parallelograms. So this is false. All kites are rhombuses. This is again false. It is actually the other way around. If you look here, if you look at the set of kites, this is kites. This is a bigger set compared to the set of rhombus over here. Okay. Therefore, all rhombus are kites, but all kites are not rhombus. Therefore, this statement is false. Next, all rhombus are kites. Now, this is true. Just now we discussed. Next, all parallelograms are trapeziums. Again, true, because you've seen that parallelograms have two pairs of parallel sides and trapeziums have one pair. So, naturally, all parallelograms are trapeziums. All squares are trapeziums. This is also true, right? If you look at this, squares are a subset of parallelograms, and if parallelograms are trapeziums, squares are also trapeziums, right? So, that is about our first question. Next, identify all the quadrilaterals that have four sides of equal length. Okay, so equilateral quadrilaterals. If you look at the definition that we have given, we have seen that equilateral is true for, let's go back to the definition. If you look here, you have seen that rhombus is equilateral and square is equilateral, right? So the answer is both rhombus and square. Okay. So here I am going to write rhombus as well as square. You can write the definition also. Next, four right angles. What are the quadrilaterals that have four right angles? This is having four right angles is nothing but having equiangular. That is, all four angles are equal, and you know that that is true for the case of rectangle and square. Okay, so if you go back here, you have seen that in the case of rectangle it is equiangular, in the case of square it is equiangular. So I'm going to write here rectangle and then square, right? Okay. Next, explain how a square is a quadrilateral. Now, a square has four sides, therefore it's a quadrilateral. Why is a square a parallelogram? Because it has two pairs of parallel lines, therefore it is a parallelogram. Why is it a rhombus? Because it is equilateral, it is a rhombus. We have discussed all this. There's the reason why I did the revision first, so that all this becomes very easy. Why is it a square? Why is square a rectangle? Because a square is equiangular and every rectangle is equiangular, right? So this is your reason. Next, coming to the fourth question, name the quadrilaterals whose diagonals bisect each other. Now this is about the properties of the different quadrilaterals that we have studied. Now, in which quadrilateral do the diagonals bisect each other? Let us see. Now here we have seen that in case of parallelogram, the diagonals bisect each other. In case of rhombus, in case of rectangle, and in case of square also, the diagonals bisect each other, because it's a property. If it holds true for parallelogram, naturally it's going to hold true for all the subsets. And rhombus, rectangle and square are the subsets of parallelogram, set of parallelograms. So the answer is all the four. Okay. So here I am going to write parallelogram, okay, rhombus, a rectangle and square. Next, name the quadrilaterals whose diagonals are perpendicular bisectors of each other. Now, perpendicular bisectors, if had they said only perpendicular, even kite would come into picture. But perpendicular bisectors is true only for rhombus and square, right? Because even for rectangle, they are not perpendicular to each other. They just bisect each other. So here the answer is going to be square, and I'm going to first write rhombus and then square. Okay. Next, the diagonals are equal to each other. Now, the diagonals are equal in the case of a rectangle and in the case of a square, but not in rhombus. So here I'm going to write rectangle and square, right? Next, coming to the fifth question, explain why a rectangle is a convex quadrilateral. Now, what do you mean by a convex polygon? All the diagonals lie inside the polygon, right? Now, here for any quadrilateral, you can draw two diagonals, okay? Now, in case of a rectangle, both the diagonals lie inside. So, if I have a rectangle and I draw the diagonals, both of them lie inside the quadrilateral. Therefore, it is a convex quadrilateral, right? Now coming to the last question. ABC is a right-angled triangle, right-angled at O. O is the midpoint of the side AC. Explain why O is equidistant from A, B and C. That is, they're saying that OA is equal to OB is equal to OC. And they want us to explain why or prove why it is equal. Okay. Now here, they have given a hint. You can extend AD and CD so that AD is parallel to BC and CD is parallel to BA, and you will get a rectangle. Now ABCD is a rectangle. And what do we know about properties of a rectangle? The diagonals are equal in length and they bisect each other, right? Now they bisect each other, therefore can I say that AO is equal to OC? Right? And because this is also bisected and they're equal in length, in fact all four are equal, that is OA, OB, OC, OD are all of equal measure. Therefore we can say that O is equidistant from A, B and C. Okay, so that is about exercise 3.4. And then after this exercise they have given 3 short questions in think, discuss and write. Let us look at them. A mason has made a concrete slab. He needs it to be rectangular. In what different ways can he make sure that it is rectangular? Now we know that in order to check that it is rectangular, first of all, what is a rectangle? It is a quadrilateral. So that concrete slab has to have 4 sides. Okay, that is equiangular, right? So now, and all the that equal angle is nothing but 90 degrees, right? So one way of checking is check that all the angles are right angles. Okay, measure all the 4 angles. If all the 4 are right angles, then it is rectangular. Okay, no problem. Or another way of checking is using the length. That is, if you measure the diagonals. Okay, if you measure the diagonals and the diagonals are of equal length. Okay, if you have diagonals of equal length and that is not sufficient, because the diagonals, there are a few isosceles trapeziums also which have equal diagonals, right? So diagonals have to be of equal length, and then you check one angle and then check one right angle, look for one right angle. That is also sufficient to make sure that the concrete slab is rectangular. Next question, they're saying a square was defined as a rectangle with all sides equal, right? All squares are rectangles, however the sides are equal in the case of square. Can we define it as rhombus with equal angles? Yes, we can do that, right? We can define it as rhombus with equal angles. Explore this idea. We have already seen rectangle means equilateral, rhombus is rectangle is equiangular, rhombus is equilateral, and square is both equilateral as well as equiangular. Okay, so you can say that it is rectangle with equal sides or rhombus with equal angles. Both of them are equally correct. Next, can a trapezium have all angles equal? Okay, what is a trapezium? With one pair of opposite sides as parallel. So yes, it can have all angles as equal. Okay, what will it become? It will become a rectangle. Can it have all sides as equal? Yes, it can. What will it become in that case? It becomes a rhombus. So here quickly let us go back to the Venn diagram. Now see, here they are saying, can a trapezium, now this is the set of trapeziums. Can a trapezium have all sides, all angles equal? Okay, that is a set of rectangles. Now rectangles is clearly a subset of trapeziums. Okay, so the answer is yes. And can a trapezium have all sides equal? What is all sides equal? It is a rhombus. Rhombus is also a subset of trapezium, therefore that is also true. Correct? So we have seen, I think you have seen that in every one of these questions, in some way or the other, we have used this Venn diagram. So what I'm trying to say is, if you have clarity of the definition of each of these quadrilaterals, then answering such type of questions, okay, like those mentioned in 3.4 is going to become very simple. Usually these questions are a bit confusing, and given the the setup of an examination and you're in a hurry, you tend to get a little confused. So have these definitions clear in your mind and these questions will become a cakewalk, right? Next, they have given a quick, a list of all the properties and the definitions like we have done along with the properties. So this is much more, neatly presented than the discussion that we have done. So, but nevertheless, it's the same. So here you can see they have given, this is what we have also done, but we have done it in a flowchart manner. They have given it in table form. They have given the definition and then the properties, right? For parallelogram, rhombus, rectangle, square, kite. There are one or two changes or additions that you can make to this table depending on, based on the discussion that we have done in this video. So with this, we come to the end of understanding quadrilaterals, which is the third chapter from NCERT textbook class 8.